Hey, how are you guys? All right, second video, or third video, I guess, technically, but the second one where we're actually just practicing problems. We have the same steps as before, so if you didn't watch video number 2, I highly suggest you do, so that way you get these steps down. Either way, we're going to go through them step by step. Oh, goodness, sorry. We're going to go through them step by step with a new problem. Our problem this time, this is a slightly more difficult problem, but at the same time, it's still fairly straightforward. So while this might seem a little tricky at first, I think this is one that you should be able to get used to pretty quickly, okay? So we're still solving systems by elimination. We have this system, 3x plus 4y equals 18, and negative 2x plus 4y equals 8. And this system is fairly straightforward in that we don't have to do any extra work with our like terms. We don't have to align them at all. But what we will have to pay attention to is step 2, where we have to think about, are we going to add or subtract? Now, a couple of things. If we were to add these, we need to say, will something disappear? Or will one of these variables get multiplied by 0 instead of by a number other than 0? So like if I added these together, we'd get 1x and 8y, so no variables are gone. However, if we subtracted them, we'd end up getting 6x's and 0y's. So cool, we have to subtract. So when you are subtracting, you can think about subtraction in a couple of different ways. And that gets into this little fine print. So let's start again. Step 1. The system needs to be aligned with like terms. X's are aligned, addition signs are aligned, y's are aligned, equal signs, constants, all aligned. Great. Step 2, we're going to now decide if we're going to add or subtract to solve this. We decided subtraction would be best. So you can look at subtraction in a couple of different ways. Subtraction, essentially, we can say 3 minus a negative 2x or something like that. Or subtraction technically is taking everything in this second equation and multiplying it by a negative number, or by negative 1. So we could say this is technically, if we multiply by negative 1, this negative 2x becomes a positive 2x. This positive 4y becomes a negative 4y. This 8 becomes a negative 8. So you can look at it in a couple of different ways. The biggest thing is you need to look at it in a way that is not going to confuse you. So if you are nervous that if you had a minus a negative, if you're nervous that going back to this subtraction every time and doing that for every single one is potentially too much work, I highly suggest you taking this second equation and changing the polarity of each of the signs for each of the terms. So negative becomes positive, positives become negative, okay? If you can go back and forth to this subtraction sign, kind of like we did with the addition problem on the previous video, then great, fabulous, continue on. I'm gonna continue like this and show you this method. However, yeah, I'll show you this method. So we have 3x minus a negative 2x. So 3x minus a negative is positive plus addition. So 3x plus 2x equals 5x. 4y minus 4y equals 0y's. I'm going to put my placeholder there with the y values. 18 minus 8 equals 10. So now I can look at that 0 times y and I can say, okay, non-issue. I don't have to pay attention to it. Don't have to deal with it. I have 5x is equal to 10. Divide by 5. Divide by 5. I get x is equal to 2. So if I were to write my ordered pair for this, I can start to see that my x is solved for. Step 3, I need to substitute this value into one of the original equations and solve for the opposite variable. If I look at these, both of them are going to be kind of messy. I'm going to avoid this negative 2, so I'm going to put it in this top equation. I'm going to say 3 times 2 plus 4y is equal to 18. If you put this value into this lower equation, it doesn't matter. You'll get the same answer, or at least you should. If you don't, we now have to second guess our actual x value, and maybe we made a mistake in this solution part of it. So 3 times 2 is 6, plus 4y is equal to 18. Subtract 6, we get 4y is equal to 12, divide by 4, divide by 4. I get y is equal to 3, and I can put that up here. Now I've created my ordered pair. I've done step 4, and now I need to check my work. So I'm going to put these 2's and 3's into here. 3 times 2 is 6. 4 times 3 is 12. 6 plus 12 equals 18. Great, that one worked. Negative 2 times 2 is negative 4, plus 4 times 3 is 12. Negative 4 plus 12 is 8. We did it. We got it. I want to show you one quick caveat so that way you can see that we'd get the exact same thing if you thought about this in terms of like changing the polarity of each of these instead. So we got our equation. We did it. If you want to stop watching, you can. If this method, though, of saying 3 minus a negative 2, 4 minus 4, if that was a little tricky for you to understand, then consider this. You can continue watching. So we have 3x plus 4y is equal to 18. And if we added these two up, nothing would disappear. If we subtracted them, though, the y's would cancel each other out. Now, what I was saying before, if you thought about subtraction, that's great. But if we thought about this bottom equation just changing the polarity of it, instead we are going to multiply each of these terms by -1, we would effectively do the exact same thing that subtraction would do, except now we can look at these two equations and we can just add them together. We can combine them. 3x plus 2x equals 5x. 4y plus a negative 4y is 0 y's. And I get the same answer as I did above. 18 plus -8 is 10. But perhaps this concept of just knowing that I can now add everything, which a lot of people will start off doing the correct subtraction, but then later on they start like adding when they should have been subtracting. They'll change up their method. If you feel like you would potentially make a mistake by potentially not going back to subtraction every single time, consider multiplying the second equation by -1. Cool? Cool. Hopefully that didn't totally like screw with your head too much. If it did, rewatch the first part of the video and stop when I said like, okay, and if this is weird. Cool. Yeah, sorry, lots of cools. All right. Thank you for watching. We have one more video, and this one's going to be a lot more intense. Hopefully it's not 15 minutes long, but it might be. Elimination can tend to be a little long the first couple of times that you try it. Either way, thanks for watching, and watch the next video if you need it. Bye.